Function notation has to do with a lot of changing or thinking of equations in terms of range domain and naming equations instead of y equals 3x squared minus 1. I can call that equation f because it is a function. And so instead of y equals, I have f of x equals. And basically, y equals f of x. And f of x is kind of saying that, f of something for x is your domain. So for f of negative 2, 2 is the domain, 2 is the input, and I want to know what is the output. And so for f of 2, if your equation is f of x equals 3x squared minus 1, in your equation, you replace the x with the 2. Instead of f of x, I have f of 2. I replaced x with 2. So that's exactly what I need to do in my equation. Instead of 3x squared minus 1, I replace x with 2. And then I follow out the algebra. 2 squared is 4, so that's 3 times 4 minus 1. That's going to be 12 minus 1. So f of 2 equals 11. If you have an input value of 2, you get an output value of 11. For the function, y equals 3x squared minus 1, which we are naming f. F of negative 3 is going to be 3 times negative 3 squared minus 1. I replace x with the f input value of negative 3. And so that's going to be 3 times a positive 9 minus 1. That's not 9, 18, 27. 3 times 9 is 27 minus 1. We get 26. So f of negative 3 is 26. For f of x minus 4, I'm replacing x with x minus 4. So 3 times x minus 4 squared minus 1. Now, x minus 4 squared is a binomial squared, so I don't just square what's inside. I have to multiply it by itself. So I can kind of think separately. All right, x minus 4 squared I know is x minus 4 times x minus 4. And that whole thing is x squared minus 8x plus 16 minus 1. Distribute a 3 in there. We get 3x squared minus 8, 16, 24x plus 16 times 3. 3 is 6, 12, 8. 3 is 48 minus 1. And 3x squared minus 24x plus 47.